Hello students, how are you? How are you doing? Now today I'm going to explain the equilibrium concept. Most of the students have difficulty in understanding the equilibrium. So let's start with the equilibrium. So first, to understand equilibrium, we should know the basic characteristics of the equilibrium. So here I have drawn one diagram. So every equilibrium reaction has four characteristics. So you can see here. So every reaction in the equilibrium, it has four characteristics. So we can see here, the reaction must be a dynamic. You can see here the equilibrium reaction has to be a dynamic. Then second thing, it should be a closed system. Third characteristics, we can see here, the concentration of reactant and concentration of product remains constant in the equilibrium reaction. Second thing, in the equilibrium reactions are represented by these two arrows. One arrow represents the forward reaction and second arrow represents the reverse reaction. So forward reaction and reverse reaction occurs at same rate. So these are the four important characteristics. Now the equilibrium best example I can give you, everyone might have experienced the carbonated drinks, right? So when we have these carbonated drinks, in these carbonated drinks, the carbon dioxide is filled in that bottle under high pressure, right? So when we release the pressure, the equilibrium is disturbed. So equilibrium, all the equilibrium reactions, the condition should be closed. It should be closed. Now one conclusion we can derive that all equilibrium reactions are reversible. Okay, so reversible reactions, all equilibrium must be reversible, but all reversible reactions are not are equilibrium. Not all reversible reactions are at equilibrium. Okay, then these are the four factors which controls your equilibrium. So first is the temperature, and second is concentration, third is pressure, and fourth is catalyst. Now how temperature affects the position of equilibrium, that is very important. Now always remember, whenever they give any equation for the equilibrium reaction, delta H is very important. So if delta H is positive, means your reaction favors the endothermic reaction. So if you increase the temperature, the reaction will proceed in the forward direction. But if delta H is negative, increase in reaction, increase in temperature will not favor the product formation. That is very important. Now this delta H value for every reaction, it is a fix, right? For example, you are melting ice, right? For ice melting, you need to increase the temperature, right? But if you increase the temperature, ice will become water, and that forward reaction is endothermic. So our delta H is positive. So increase the temperature, a reaction will move towards forward. But the reverse, if you want to, if you decrease the temperature, so ice will not melt. Okay, in that case, delta H positive is value. But if you are increasing the temperature, it is not favoring the delta H, where it is positive. Second thing, we have concentration. So if you increase the concentration of reactant, the product concentration will increase. Second thing, if you decrease the concentration, the product concentration will also decrease. How? Now suppose you are doing a reaction, and if you increase the concentration of a reactant, definitely equilibrium will shift towards the right. Okay, and if you decrease the concentration of reactant, equilibrium will shift towards left. Similarly, if you decrease the concentration of reactant, the position of equilibrium shift towards left. And if you increase the concentration of product, again in that case, the reaction will come to the proceed to the left hand side. Now second thing, we have effect of pressure on equilibrium. So I have written these three equations of equilibrium. So first one is the Haber process, second one is a reaction of hydrogen with I2, we get 2Hi, and third is 2NO2, we are getting N2O4. Now how pressure affects the position of equilibrium, this is very important. Now for how pressure affects the equilibrium, to understand that, you should know and you should consider only the reactant and the products which are in gaseous state. So only the only the reactants and products which are present in the gaseous state, only we consider that, right? So total, you can see here, I have 1 mole of N2, I have 3 moles of H2, so total moles are 4. On product side, the total moles are 2. So in this case, I have to increase the pressure. If I increase the pressure, right, so equilibrium will shift towards right. And if I decrease the pressure, equilibrium shift towards left. Second case, you can see here, I have H2 and I have I2. In this case, both the side, the moles of reactant and product are same. I have 2 moles of H2 and 2 moles of, I have 1 mole of H2, 1 mole of I2, and total moles are 2, whereas on the product side I have 2 moles of product, right? So reactant side 2 moles, product side 2 moles, so overall moles on both the sides are 2. So reaction has no effect on increase or decrease in a pressure, right? And the third reaction you can see here, 2NO2 with equilibrium sign, we are getting N2O4. Same thing here, 2 moles become 1 mole. So even I have to increase the pressure. If I increase the pressure, equilibrium shift towards the right. Now same reactions I can write in reverse. For this reaction, decrease in pressure, right? We shift the equilibrium towards the left hand side. And the last fourth important factor is catalyst. So always remember, catalyst has no effect on position of equilibrium, but catalyst attains the equilibrium very fast. The reason is the rate of forward reaction increases fast. Similarly and simultaneously, the rate of reverse reaction also increases. So in this way, the catalyst has no effect on the position of equilibrium. So I hope you have liked the video. Please like and share. Next video we can see some questions from the past paper. Then definitely we'll understand the equilibrium concept. Thank you.